Okay, let's get started on Unit 9 here. This is Section 9.1, and our objective is I can dilate a polygon given a center, so let's write the word center right here, and a scale factor. So dilations with polygons using a center and a scale factor. Your teacher may give you an equation for the day. We'll skip that one for right now. And then we're going to recall a couple things. So recall that similar figures have the same shape but different size. And what this means is the sides are proportional and all the angles are congruent. So the sides are proportional and the angles are congruent. They're exactly the same size. And we'll be doing dilations that transform a figure into a new figure that's similar to the old figure. So we don't have to worry about things not being similar. They're definitely going to be similar. And in order to perform these dilations, we need two things. First thing we need is a center, and we also need, like we mentioned up above, we need a scale factor. Now, you'll recall from maybe some things that you did before, the original figure is called the pre-image. Okay, that's what the figure that we work with before we make the new one. And the new one is called the image. So make sure you don't confuse those. Pre-image is what we get before we do the transformation. Image is what we get after. And we also use prime notation. It looks like a little apostrophe right there. That's prime notation, and prime means new. So that's all the word prime means. And the reason the image is similar to the pre-image is that all the new angles are still congruent to all the old angles, and all the new sides have grown or shrunk, and here's a key word, proportionally to the old sides. Okay, so the center of dilation, it's a fixed point on the plane about which all the points are expanded or contracted. So we're going to use that point, and then we're going to kind of stretch everything from that point or shrink everything toward that point. And then the scale factor, again, that's going to tell us how much we increase the lengths or decrease the lengths. And we're going to do that through multiplication. So most of the time we're told what the scale factor is. And if we're not told what the scale factor is, we can find it pretty easily by just comparing the ratio of lengths of the new figure to lengths on the old figure. Now, the scale factor is going to look something like this. All we need to do is find a new length and divide it by an old length. Now, on this particular one, it's pretty easy because we can tell on this one right here, like let's take RQ. So the distance from R to Q, 1, 2, 3, that's 3 spaces. And then R prime, Q prime. Again, this is the old one right here, and this is the new one because it's got the prime notation on it. So RQ is 3, and R prime Q prime, if we count here, 1, 2, 3, 4, 5, 6, this is going to be 6. So we do the ratio of the new length to the ratio of the old length. So this is R prime Q prime over RQ, and we get 6 over 3, and we end up with 2. Now, you're going to find that a lot of times, just for the sake of size and convenience and working with fairly nice numbers, a lot of times a scale factor of 2 is pretty nice to work with. Now, the key on this is using horizontal and vertical lengths. So I picked this horizontal length with RQ and compared it with the horizontal length R prime Q prime. We could just as well have found the distance from P to Q and compared it with the distance from P prime to Q prime, but those are diagonal and that makes things a little bit more difficult. So we'll try and avoid that when we can. Sometimes it's unavoidable and then we might have to do that. So I'm going to zoom in on this next one. This next one's an interesting figure. It's rotated just a little bit. So we've got the old one is the small one on the inside, and the new one, so here's A prime, B prime, and C prime, that one's a little bit bigger. So we know this has been, the scale factor must be bigger than 1 because it got bigger. But you'll notice that these are diagonal lengths. If you want to go to the trouble of finding each one of those diagonal lengths using the distance formula or something like that, then that's totally fine. Another way to do it is to do this. Let's take a look at how we got to B. So B is over 2 and up 1. So if I were to compare these horizontal and vertical distances, and I'm going to change colors here, with this horizontal and vertical distance right there, I could come up with this. I could say, well, from the x-axis up to B, that's a 1, and from the x-axis up to B prime, that's 2. So I could do 2 over 1, and I could maybe take a guess that everything's been stretched by a factor of 2 or dilated by a factor of 2. The other thing that we could do is we could say, look, this point B is 2, 1. There's the horizontal distance of 2, and then there's the vertical distance of 1. And then at B prime, we have this is, let's see, that's over 4 and up 2, so this is 4 comma 2. And then we can just make a comparison between each one of those horizontal and verticals. So in other words, between the x-axis and the y-axis. So if I do B prime on the top and I do B on the bottom, I could do 4 over 2, so just comparing the x's, 4 over 2. And if I compare the y's, I get, let's see, this would be 2 over 1. In any case, we end up with a scale factor of 2, and it kind of looks like that got twice as big. Now, if you want to watch an animation of some stuff like this, there's an 8-minute video, decent video on YouTube where you can take a look at that, and it'll talk about how we translate these, and there's some decent animations there. So these were both dilated and stretched from the origin. They both got bigger. They don't always get bigger, sometimes they get smaller, but we're going to focus for the time being on dilations centered at the origin. They're the easiest, and it's pretty simple because all we have to do is multiply the coordinates by the scale factor. That's it. That's all we need to do. Now, we've got the convenience here of having these already graphed. So we've got a vertex of 1, 1 for A, so already graphed there, 4, 1 for B, and 4, 4 for C. And we're going to dilate these with a scale factor of 3, centered at the origin 0, 0, and we're going to use prime notation on the image. So I'm going to take each one of these, and if it's centered at the origin, and this is the key, all we have to do is just multiply each one of the coordinates by the scale factor. So A prime is going to be at 3, 3. B prime is going to be at 12, 3. C prime is going to be at 12, 12. So let's see what we get here. 3, 3, so over 3 and up 3, so that's going to be right there. There's A prime. B prime is going to be at 12, 3, so over 12 and up 3, so there's B prime. And then C prime is at 12, 12, way up here, so there's C prime. So here's what it looks like. So this is the new one. Okay, and we've got the prime notation indicating the new one. So that's what it looks like when we dilate that one by a factor of 3. It gets 3 times bigger, and if you'll notice this length right here, let's just double check. This used to be 3, and now let's check and see what it is. There's 3 and 6 and 9. This is 9. So if we were to compare those, then they definitely would have the new length over the old length. They match up with what the scale factor is, and you can kind of tell that that's a right angle and that's a right angle. And you can tell that this is on a perfect 45, so everything should match up. The sides are proportional and the angles are congruent to the old angles. So now what we want to do is on example 3, we want to dilate the parallelogram with vertices negative 4, 4, 6, 6, 6, negative 2, and negative 4, 4. So we'll just kind of double check those. Those are all in the right place. Looks pretty good. And we want to use a scale factor of 1/2 centered at the origin. So again, what that means is we're going to end up making each one of these half the size as what they were before. So at the origin, piece of cake. All we're going to do is we're going to take every single one of these and we're going to multiply the coordinates by 1/2. So this is going to be negative 2, 2. B is going to be 3, 3. Whoops, B prime, sorry. C prime is going to be 3, comma, let's see, half of that is negative 1. And then D prime is going to be negative 2, comma, negative 2. And let's graph these and see if it looks like this has been shrunk by a factor of 2, or sorry, factor of 1/2. All the horizontal and vertical measurements should be half the size of what they used to be. So A prime would be negative 2, 2. So there's A prime. B prime would be 3, 3. Looks okay there, B prime. C prime would be 3, negative 1. Looks good there. And D prime would be negative 2, negative 2, so D prime. So we'll go ahead and draw this figure and kind of just make a visual comparison. And a couple of things that we notice is, gosh, it sure looks like A prime, B prime is about half the size there. And the other thing that you'll notice is this is straight up and down, and so is that. And it looks like that's parallel. So this angle would be congruent to that angle right there. Just kind of something to note for right now. So we've got the prime notation, we've got everything done there. So let's take a look at the other side. Now, it can get a little bit more difficult when dilations are not centered at the origin. And we've really got to pay attention to this because it is a bit more complicated. But the key again is focusing on horizontal and vertical lengths in order to figure this out. But we do have to make sure that we're using the center of the dilation because it's no longer at the origin, so we've got to be a little bit careful about this. So it says, dilate the square with vertices negative 1, 1, negative 4, 1, negative 4, 4, and negative 1, 4. And it says by a scale factor of 2, so there's a nice easy scale factor for us. And then the center is at negative 4, 4. So here's what I'm going to do. I'm going to put a big black X wherever the center is. So the center is at negative 4, 4, so back 4 and up 4. So it just so happens, and this is kind of nice when this happens, if the center of the dilation is a point on the figure, makes it really easy, especially for that particular point right there, because if we were to stretch that, dilate it by a scale factor of 2, we're stretching everything, we're making it twice as far away from this point as it used to be. Well, if it's on that point, it just stays right there. So this is where C prime is going to be. So this is going to be C and it's going to be C prime. So I'm just going to mark that. Now again, focusing on horizontal and vertical stretches and shrinks, dilations with a factor bigger than 1 or smaller than 1. Here's what we're going to do. I'm going to take C prime, I'm going to leave it right there, and then I'm going to work my way around here in a clockwise way. So I need to make this point, D, I need to make it 2 times as far away from C. So if this is 3 right here, I need to make it 6 units away in the horizontal direction. So another 3 units would put it 6 units away. This is going to be D prime, so that's where that one would be. I'll do the same thing with B. This is 3 units down here, and it did tell us that it was a square, so that's kind of nice. So this is 3, so this needs to be twice as far because the scale factor is 2. So if this is 3, I need to go another 3, so that's going to be B prime. And then A, we need to do 2 things with this. All we needed to do with D is move it to the right, make it horizontally twice as far as from C as it used to be. With B, all we needed to do was make it twice as far vertically from where it used to be. But with C, we need to do 2 things. We need to move it twice as far to the right, and we need to move it twice as far down. So if it was 3 units to the right and 3 units down, we're going to need to go twice as far. So that's going to be 6 units to the right and 6 units down, and that's going to put us right here. That's where A prime is going to be. So if we draw that, then we've got a square. You can tell that all the angles are still right angles, and you can just visually inspect that, and you can say, yeah, all of the sides, all of the lengths are twice as big as they used to be. So the proportion from this side to this side, whoops, I'll do this. I'll do 6 and 3 is 6 over 3, so that matches up with the proportions that we were after. Okay, and we'll talk more about that in just a second. So let's write down what the coordinates are. A is going to be 2, negative 2. B is going to be negative 4, negative 2. C gets to stay right where it was, negative 4, 4. And D is going to be 2, 4. Okay. Now, is the image similar to the pre-image? Well, that's an absolute yes. And it says list 2 corresponding angles that are congruent. Well, let's just pick some easy ones. So let's say angle D is congruent to angle D prime, and we could have gone through and picked any one of those that we wanted. And it says show that 2 corresponding lengths are proportional to the scale factor. So let's do A prime D prime over AD. This is the one that we noted right there. So A prime D prime is 6. A to D is 3, and again, notice that that matches up with the scale factor of 2, so we're all set to go. Looks pretty good. We're going to slide down here and take a look at the next one. The triangle, it says here, is not drawn for us, so we're going to need to start with that. So I'm going to change colors. I'll do this in blue. So A is negative 1, 1, so negative 1, 1 here, and I need to label that as A. And then B is negative 7, 7, so back 7 and up 7, so there's going to be B. And then C is negative 9, 1, so we're right here, that's C. And then I'll go ahead and connect those, and I'll use a different color for the next one. And again, forgive me if they're not the perfectly straight lines that you might see elsewhere. So the next thing is we're going to dilate this by a scale factor of 0.5, so 1/2. Okay, and the center is going to be at negative 1, 1. So I'm going to come back down here, and let's do negative 1, 1. Negative 1, 1, so we're right here. Okay, now again, like I mentioned, if a point on the figure happens to be at the center of dilation, we don't have to move that one at all. It just gets to stay there because when we dilate it horizontally and vertically from that point, well, if it's on that point, it doesn't get to go anywhere. So all we have to do is just dilate and change the coordinates of B and C, and we'll be all set. So let's take a look at B. And again, we're not going to, what's going to end up happening is this is going to shrink by a factor of 1/2 back to where A is, back to the center of dilation, but we're going to do it horizontally and vertically. So horizontally, this is to the left, that's 6 units, and vertically it's 6 units up. So if we multiply that by 1/2, by 0.5, we're going to go 3 units to the left. So 1, 2, 3, and then we're going to go 3 units up, and we're going to end up about right there. And I need to change colors here. So we've got that point right there. So that's going to be where B prime is. And then C, this one's a little bit easier because you'll notice that it doesn't have a vertical or vertical distance from A. It's just literally horizontally left. Let's see, 2, 4, 6, 8. It's 8 units to the left, so we need to shrink that by a factor of 1/2. So half of 8 is going to be 4, so I'm going to do 2 and 4, so we end up with right here. This is going to be C prime. So here is what the new triangle looks like. Now, a couple things that we'll notice, and I'll answer this question first. Is the image similar to the pre-image? Well, that's an absolute yes. And the reason that we know that is a couple of things that we have to check for. Well, if you just look at angle A and angle A prime, those two are congruent. Okay, this is heading off in exactly the same angle. This is clearly horizontal, so that angle is congruent. Angle A is congruent too, and I ought to put an A prime on here. A prime is right there also. Those angles are congruent. And if I were to check a distance right here, if I were to compare the distance from A prime to C prime, so A prime to C prime, that we said was 4, and the distance from A to C, we said that one was 8, so there's our scale factor of 1/2. So there's a couple of reasons why. And then all we need to do now is just the easy part of writing down the coordinates. So again, the coordinates of A prime, -1, 1, doesn't change at all. B prime is going to be -4, 4, -4, 4 there. And then C prime, remember, it didn't change vertically at all, so that's still a 1. And then we did 4 back here, so that's going to end up at -5. Okay, so there's what we've got on that one, and let's come down and take a look at, I think this is the last one on the notes. It is, so we're in good shape there. It says dilate the quadrilateral with vertices, these guys right here, already graphed, we'll assume all that's correct, and we want to do that by a scale factor of 2, and we want it centered at 3, 5. Now, at first glance, we might think, oh yeah, I've got a 3, 5, I'm all set to go. But it's not -3, 5, it's 3, 5. So let's find where that point is. So 3, 5 is right here, okay? So 3, 5 is right there. There's the center of our dilation. And what we want to do is we want to dilate everything by a factor of 2. So that means all the sides are going to get twice as big, but the angles are going to stay the same. They're going to be congruent to the old ones. So let's kind of just work our way around. This one is only a vertical distance of 1 from the center of dilation. So we need to multiply that by 2. We don't have to change it horizontally at all. So I'm going to come down here. This is going to be A prime. B is, let's see, down 2, 4, 6, and then to the left 1. So if we double both of those, we're going to have to go down 12. And then we're going to have to go to the right, or sorry, to the left 2. So that's going to put us right here. Yeah, let me just double check here. And again, don't get confused. I'm not counting from A. So this is going to be 2, 4, 6, 2, 4, 6, because I'm going twice as far. And there's 1, so I have to go twice as far. So that looks pretty good. So there's B prime right there. Let's do C. I have to go down 2, 4. So I have to go down 8. And then 2, 4, 6. So I'm going to have to go down 8. And if I double, so this is down 4, that's 8. And that's 6, that's 12. So I have to go down 8 and to the left 12. So 2, 4, 6, 8. And then 2, 4, 6, 8, 10, 12. That's going to put me right here. So that's going to be C prime. And then D, we get a little bit lucky on this one because it says, let's see, we have to, well, this is, all we have to do is change the horizontal distance from the center. And this is 3 and 6. So that's going to be 6 right here. I have to double that, so I need to go 12. So here's 3, 6, 9, and 12. So this is D prime. Now, it makes us feel a little bit better that D prime ended up in the same horizontal position as C prime did. So let's draw this. Okay, and I'm going to come back and draw that one again because clearly that's not a very good vertical line. I can do better than that. There we go. And if we take a look at this, this one is a little bit harder to tell, and maybe if I drew properly it would look a little bit better. It's a little harder to tell that, yeah, these are actually, they're still similar. If you take a look at this right here, this is straight up and down, and we could compare a length right here. So this is a length of 4. And that is a length of 2, 4, 6, 8. So yeah, we've got 8 here and we've got 4 here. That's going to be good. And then another thing that we can notice, now we don't have any right angles or anything nice like that, but if you'll notice, this is vertical and that's vertical. And if we were to check the slope of this line right here and the slope of this line right here, so the slope of DA, if you were to check that, it would actually match up with the slope of D prime A prime. So we should be in good shape. So it says, what are the coordinates of the new vertices? Let's just run around and write those. So this is going to be 3, 3. B prime is going to be 1, negative 7, looks right. And then C is going to be negative 9, negative 3. And then D prime is going to be negative 9, 5. Okay, so we've got that. And then it says list 2 corresponding angles that are congruent. So let's go ahead and list angle D prime is congruent with angle D. Okay, so that angle is congruent to that angle, and we kind of already talked about why. That one's straight up and down, and that one's straight up and down. And if those two lines are parallel, then that angle would have to be the same. And then it says show that the 2 corresponding lengths are proportional to the scale factor. Again, we do the new one over the old one, so I'm going to do D prime C prime over DC, and that's 8, and that's 4, so we end up with 2, so that matches up with the scale factor. All right, that's how we do dilations on the XY plane. Good luck with the assignment.